The screen, you were seeing a little display of the velocity, the altitude, the force, and the time. Okay, so what am I doing? I'm really starting with a string. I have a constant. I'm formatting. In this case, we're talking about velocity. So this is the rocket's velocity in the x direction and the rocket's velocity in the y direction. And I'm using format. By the way, notice my format has a blank in it. So it will prefix the display with a blank. Okay? So these things will not run into each other. Okay. Also notice that I'm just building up this string. I'm using the /n. Do you remember what the /n means? What does the /n mean? It's a special character. There are a bunch of special characters that begin with a slash. Do you remember? Okay, it means new line. Okay, so when I display it, this will show up on the first line, this will show up on the next line, next line, next line. So originally I was displaying it 4 times, and I decided that was too much work. So now that I have a string, the graphics package has a notion of a text, so I'm going to display a text object at a particular point on my screen, and I'm going to, and the thing I'm going to be displaying there is the string S. Okay? That's what text does. It has a location and an object that you want to display. I'm going to set the color to be light blue. And finally, I'm going to draw it in my window. Okay? So that's what draw text does. It basically displays that kind of scoreboard. Okay, finally, the lander itself. All right, if we think about this check mouse business, what is that? How does that correspond to one of these? How does check mouse correspond to one of these? Is it the model? Is it the view? It is the controller, yes. Basically, it's sensing how I've clicked the mouse, where I've clicked the mouse, and interpreting that mouse click as basically a command. Okay? All right. I'm now going to do the lander, which is basically, well, it actually probably combines the model and maybe a bit of the view. We'll see. All right. So, it has a bunch of global variables, the text, the rocket accelerations, the rocket forces, and what the window is. Okay. So we're going to set the time equal to 0. We're going to set dt, which is basically the increment of time. So basically I'm going to take 50 milliseconds between refreshes of the screen. So you can do it faster and things get smoother. If you do it slower, things look jerky. Okay? If you try to do it too fast, you can't keep up, basically. But I found that 50 milliseconds is a good interval. All right. All right, so we're going to create a window, and there is an object called graph window. And it, at the top of it, let's see, do I still have the thing running? No, I think we're done with that. That's not what I want. Let's run it again, just to remind ourselves what we're seeing. Okay, so basically this window is the WIN variable. Okay, and notice one of the properties is the title up there that says rocket. Okay. So I'm going to kill it for a moment. Okay, And I have basically said that it's 1,000 pixels by 800 pixels in size. So that creates my graphic windows. In Tinker, you can think of a game coordinate system that is different from your window pixel coordinate system. But in my case, I thought it was too complicated to make them different, so I made them exactly the same. So I'm sending essentially what, you can, for example, decide that the left side of your graphic window is a 0 and the right end is a 1, if you want to plot things between 0 and 1, for example. But you would not want 1 pixel graphic screen, that would be silly. All right, so I have draw buttons. I think you saw what the buttons were. They were just rectangles. I initialize my rocket properties. So let's go through those. The x coordinate of my rocket is 100. And again, this is against those coordinates. My y coordinate is 7,000. These are in units of meters, by the way. So 100 meters, 7,000 meters. The velocity is 15 meters per second in the x direction. It's 0 in the y direction. Initially, my accelerations are 0. Initially, my force is 0. What was RM? I forget what RM was. Oh, rocket mass. How heavy is my rocket? One could do some complications there. Right now, I'm keeping my mass of my rocket constant. You can sort of think that in a real rocket, as you're using fuel, its mass would get lighter and lighter. But I haven't introduced that. I'm assuming our fuel is negligible compared to the rocket mass. Okay. And finally, we have 500, if you like, liters of fuel available to us, which actually would be almost half of that rocket mass. Okay, so not totally consistent. Okay, so while the rocket y coordinate is greater than 100, we're going to go through this loop. Okay? First of all, we're going to increment our time by our delta t by 50 milliseconds. We're going to get a mouse. We are going to draw a rocket image. Where are we going to draw it? At the rocket x coordinate and rocket y coordinate. For scaling purposes, I divide that by 10. And what am I going to draw at that? Well, this is an external object. It's actually a file. Okay. Everybody familiar with a GIF? A GIF is an image file. And off the web, if you do a Google search of images of the lunar lander, I picked one that sort of, anyway, seemed the right one to me. And that's what you were seeing in the picture. So basically, I am, and this is another object called the image. I'm giving it a name, rocket image, and I'm going to draw it. Okay? And that image has coordinates, so I know where to draw it on my screen. Again, I'm doing this every 15 milliseconds. I'm then drawing a flame. Remember the draw flame routine, the 3 triangles? Okay. I'm now going to undraw the rocket image, erase it. I'm going to undraw all the text that I wrote. I'm going to decrement the amount of fuel, which is related to the amount of force. And these are absolute values because I'm using the same amount of fuel if I'm firing the rocket up or down or right or left. Okay? And here's where some physics comes in. I'm just saying that the rocket acceleration in the x direction is 40 times the rocket force in the x direction divided by the rocket mass. So this is Newton's second law in action, basically. Okay, slightly different formula for the y direction because gravity only operates in the y direction. So the first thing I do is I say there's an acceleration downward, and I'm using Earth's acceleration divided by 6. Roughly speaking, the moon has 1/6 of the gravity force of Earth. Still has one. So I just use the famous negative 9.8 for Earth and divide it by 6. So that's the acceleration. But that's modified by whatever rockets you're using in the y direction. So basically those define the motion of the rocket over time. It's changing its velocity, first of all because of lunar gravity, and secondly because you're using rockets. Okay? All right. Now, the next line, we're actually doing the velocity change. So the rocket velocity in the x direction is incremented by the acceleration in the x direction times the delta t. Similarly in the y direction, and then the rocket position in the x is incremented by the velocity in the x and the y direction. Okay, so those are the basic, if you like, kinematic equations. So for example, how many of you have played Angry Birds? Okay, when the bird, what does he throw something? Is that right? I'm not a player. What does he do? He throws something.
Throw the bird itself.
He jumps. Okay. So he's operating in a ballistic path under the influence of gravity. And it's basically the same equations. Okay? Or if you've got a baseball and you're throwing it, or a cannonball, all those are essentially the same equations. And they apply to a rocket. The only minor difference here is most of these equations we talk about on Earth. So it's just plain 9.8, negative 9.8. But here we're on the moon, so we have a weaker gravity. Okay? All right. So we've done a rocket. Okay. I'm not sure why we're doing this again. Huh. Trying to figure out my own code. Okay, so this is in the loop. We're constantly updating the lunar image. We're undrawing it and then drawing it again. I think at some point this is no longer true. We're below 100 feet, 100 meters. I think I want to draw the image again. Okay, and draw that. Okay, that's basically the code. How many lines of code is that? It's about 58 lines of code. Okay, so in this case, what was our model? It's really a simple model in this case.
Rocket?
Essentially, it's the rocket's position in the xy coordinate, its velocity in xy, and its acceleration in xy. Okay? That's our model. Really simple model from a physics point of view or from a computing point of view. Some models get much more complicated. For example, I might have multiple rockets floating around. All right. What was the graphics? I am using tkinter here. And tkinter has notions like a graph window. It has notions like an image, which we can manipulate. It has notions of polygons, so we use those for the triangles. It has notions of text fields, so we can display text at various points in the image. And text can have colors, for example. It has a notion of a point. So tkinter is basically using these graphic objects to describe things. Okay. Any questions about this game? Seems to have a minor bug. I don't know, it's not ending the way I want it to end, but I don't want to fix it right now. Okay? All right. Let's go through a more complicated game. And this one may take a while and may have some concepts in it that are relatively new to you. But we're going to go through it really slowly. I'll show you the game first, and then we'll... All right. By the way, this game is still under development. I'm working on it. Actually, I'd appreciate your input, because again, I'm not much of a game player. I just kind of like the concepts. All right. So this is kind of a World War II level war game, but it's not a shoot 'em up game like Call of Duty. It's more of you are the general commanding units in the field. So this funny thing is the map, and it's a little too regular, but essentially each color on the map, it's a 25 by 25 array of squares. Each color on the map represents a different kind of terrain. So, for example, yellow represents a relatively open field, green represents a forest, brown represents mountains, blue represents water, like a river, and gray represents a road. So how does terrain differ? Well, the other thing we have is units, and there's a list of units, and there's a list of units. By the way, units come in a red and a blue nationality, okay? And there are different kinds of units, infantry, cavalry, armored, and artillery. They can move, and they can shoot, and they can be shot at, okay? It's a war game, all right? So each unit has a position on the screen. These are units, by the way. For test purposes, I had them all moving toward the same point, so they're now all clustered right near the center. And for test purposes, I had the red guy firing at the blue 1st Infantry, and the blue side, everybody fires at the red 1st Infantry. So every unit has a population. It starts off at 1,000. But notice that these 2 infantry units have been taking casualties, and so their populations have dropped. In addition, everybody has some supplies, and as you're moving or firing, you're using up supplies. Okay?
Okay.
All right, so let me restart the game. Just to... This the right game? Yes. Take a look at some things. Okay, notice the units, like the 1st Artillery here, it's moving. And everybody's moving toward, right now, just for test, a point in the center. Okay? As they're moving, they're firing at the 2 infantry units. And so its population is going down, and everybody's supply is going down because everybody's firing. Okay. So when we ask what is the view of this game, it's basically this window right here. Let me move it a little bit. Okay, this is what the player sees for the game. He sees the units, he sees the geography. There's kind of a scoreboard that tells you a little bit about the skill of each unit. Okay. We also have a controller. And this controller is this other window over here. Oops. Didn't mean to do that. There we go. Okay, so this is a GUI window, and we notice it has some widgets in it. It has a list of target units, so when you say you want to fire at a unit, you have to select which unit you're firing at. It has some buttons, and unfortunately, I did this on another computer which I think has a different graphic resolution. I wasn't being too careful about determining what the graphic. There is a way you can find out what the graphic resolution of your screen is and make adjustments. I didn't do that. So these fire and move buttons should be moved down a little bit. Actually, we can do that in a couple of minutes ourselves. Okay, so if I press the fire button, and again, this is under development, it's not done. This is a part that's still under development. right. Console window. Okay, oh, all right, I haven't picked something. So if I pick something like blue Cavalry, and I press fire, okay, this is kind of debug data, but on the console I'm saying I have picked the second item in the list to be the target. So it's not actually firing yet, but the selection process is working correctly. All right. So that's what the fire did. You have to select a target unit, and that's what the label says, and you have to press the fire button, and presumably at that point you're firing at that target. And again, I think what I really need to do is first of all decide which unit does the firing, because right now everybody does, well, right now nobody's doing the firing, but I think I have to add another selection. In fact, I think I'm going to divide this list into a blue list and a red list. So if you're the blue side, you have to decide which unit is doing the firing and who his target is. Okay? Haven't done that yet. Secondly, there's a move button, and the idea is you put in a destination. So let's do it 4, 5 as a destination, and then hit move. Okay, at the moment all that's happening is something called move order is printed. Clearly there's more code that has to be written to interpret the 4-5 and cause the unit to have as a destination that. Okay, so that's the controller. I haven't really talked about the model because that's going to be a fairly long talk all by itself, which I think might be a good idea to have our break right now. So we're going to take a 5-minute break, okay?
Wait,
And I'll be back in a couple of minutes.
can you like send me the like thing?
Yeah, as a matter of fact, remind me when I come back. I'm going to send you all this code.
Okay.
But I'll be back in a couple of minutes.